Hello, Song here. I'm going to do a demo of liquid creatine kinase, or total CK, for you today. So let's take a look at what I have out. In front of me, in no particular order, I have is the product insert. Then I have the expected results for chemistry control level 1, expected results for chemistry control level 2. We also need our reagents. So here it is, liquid creatine kinase. Inside has 2 bottles, reagent 1 and reagent 2. Let's see. So we have more volume of reagent 1 and a smaller bottle, less volume of reagent 2. I also have a beaker of deionized water, a timer, my QC level 1 and QC level 2 chemistry control, a cuvette incubator set at 37 degrees Celsius or body temperature, our cuvettes, our spectrophotometer, which is the Genesis 5, pipette tips, Kim wipe, cuvette rack. Here this is a plain glass test tube, parafilm. I have a pen, a Sharpie, blank paper to do my notes, and semi-automated pipettes, and a waste bin. So that's everything you'll need to do this lab. Before you can even start, you have to make your working reagent, and that's what step 1 says to do. And to make it, they suggest doing 4 parts of reagent R1 to 1 part of reagent R2. And easy math for that obviously would be 4 milliliters of reagent 1 to 1 milliliter of reagent 2. But when you think about your roster, we are just going to be running QC1 and QC2 and possibly a patient. For the demo, I'm just going to be running the 2 levels of QC. So I do not need to make 4 mLs plus 1 ml of working reagent, because that would give me 5 ml total. I only need 2. So I'm going to cut the reagents in half. So I'm going to do, let's see, that would be 2 mLs of working reagent 1 to half an ml, or 500 microliters of reagent 2. So I'm going to make that now. Okay, so I'm going to make our working reagent. So here is the box of the reagents. It's in the box because it says it has to be protected from light, so I'm going to minimize its exposure to light. So I have R1, R2. Like I said, I'm going to reduce the suggested volume from 5 to 2.5. So I have 1,000 microliter pipette. I have that set, so I'm going to pipette 2 mLs into a tube. So of course I'm going to label, because that's good practice. So I have the name of the solution, the dilution factor, the date, and my initial on here. I'm going to give this a gentle inversion mix. One ml. Two ml. Next, I'm going to add 500 microliters of reagent 2, or R2. Gentle inversion. A pipette set to 500 microliters. Put my reagents back in the box to protect it from light. Get a little piece of parafilm. Cover the top of the tube. Give it a good mix. And you don't want to create any bubbles throughout this whole process when you mix anything. And now my working reagent is made and ready to use. Step 2 of the procedure says to pipette 1 ml of working reagent into appropriate tubes and pre-warm at 37 degrees Celsius for 4 minutes. The first thing you need to know is how many tubes or cuvettes you'll need. I'm going to use 3 today. So I have these 3, and of course you need to label. My first tube I'm going to label B for blank. Next tube I'm going to label as QC1 for chemistry control 1. And the third tube I'm going to label QC2 for chemistry control level 2. So I place that in the cuvette rack. And I'm going to have my working reagent here. I'm going to get a pipette, and like it says, I'm going to pipette 1 ml working reagent into each tube. So the working reagent is only going to be for QC level 1 and level 2, because if you read the next step already, that's coming up, we're actually blanking it with water and not reagent. So even though I mixed it earlier, I'm just going to give it another gentle swirl. Deliver the first ml to QC1. Deliver the second ml to QC2. So after that, it says to pre-warm at 37 degrees Celsius for 4 minutes. So I'm going to take these 2 cuvettes and stick it into the cuvette incubator. And then set my timer for 4 minutes. And then we wait. Step 3 says to zero spectrophotometer with distilled water at 340 nanometers. So I already have my cuvette that's labeled B for blank. I have my beaker of DI water. This instrument requires 1 milliliter minimum to measure anything, so you do not have to be exact. I'm just going to use a disposable pipette and get more than 1 ml. And dispense that. So of course you need to select your program. We're going to use option 1 for absorbance. It's loading. So I'm going to put my cuvette in position 1. I'm going to put the phone down for a second to wipe it with a Kim wipe because I don't want any fingerprints on it. Okay, so I just wiped the cuvette. I'm placing in position 1. By default, the instrument's going to pick the last absorbance used and it's going to start in position 2. I'm going to move the cell button down to position 1 or B for blank. I'm going to hit go to WL to change the wavelength, and the procedure wants us to use 340 nanometers, so I'm going to type 340 and then hit enter, and it will adjust the wavelength. So the wavelength is now set to 340. I'm on position 1 or B for blank, but now I need to auto zero to blank it out, and that's buttons right there. So the last number might fluctuate, but that's okay. So we are ready to run our test. Okay, so my timer's going off, so it's been at least 4 minutes. Step 4 says to add 50 microliters of sample to its respective test tube and mix gently. After the first 2 minutes, it wants us to read the absorbance and then return the cuvettes back to the 37 degrees incubator. And we're going to repeat that every minute for the next 2 minutes. And the rate should be constant. So I'll show you that now. I have my pipette set to 50 microliters. Got my bottle of QC. I'm going to be very careful and go ahead and pipette the QC right into the cuvettes while it's in the incubator. So of course you want to give it a good swirl or inversion to mix your QC before you dispense. Kim wipes ready. So you're going to have to be very quick yet careful with this procedure. Have my parafilm. Gonna give it a quick mix. Start my timer. So I'm not gonna set it for 2 minutes at a time and keep hitting start and stop. I'm just gonna let it keep going and know at every 2 minutes. So at 2 minutes, 3 minutes, 4 minutes, and so on, I know I need to switch it out and measure on the spectrophotometer. So now that the QC is mixed with the working reagent, we're gonna wait the first 2 minutes and then record the first absorbance. In the meantime, I got my roster ready. So after 2 minutes, I'm gonna measure it, and that's gonna be my first absorbance. A minute after that, I'm gonna write my second absorbance, and a minute after that, it's gonna be my third absorbance. So I'm gonna have 3 readings each for each level, except the blank. So 2 minutes is approaching, so I'm going to get everything ready. I'm going to open the lid of my spectrometer. And now it's been 2 minutes. So I'm going to put QC1 in position 2 and QC2 in position 3. And I'm going to move the cell button up to read. And as the instruction says, return it back to the incubator. So because this is a kinetic reaction, the value of the absorbance is constantly changing. You just have to write the first number that you see on the screen as soon as you put the cuvette in. So 1 minute is fast. You're going to have to be really careful and know what you're doing for your next step so you don't miss the timing of this. So I have about 10 seconds until another minute has passed. So the same thing I'm going to do, I'm going to open the lid to get it ready. And now it's been a minute. I'm going to place my cuvettes in again in the correct position and read. And then I'm going to return it back to the cuvette incubator for one last time. And then I'm going to wait 1 minute to do the next reading. You do not have to do it the way that I'm doing it. If you're not comfortable moving at this speed, you can do one sample at a time, start to finish, before adding the QC. It'll take a little longer, but it'll be a better quality and a better result you'll get. So the next minute is approached, so I'm going to go ahead and read that. So I have all three readings, so now I need to calculate the results. Step 6 and 7 tells you to calculate the results based on this formula. So let's take a look at my data sheet first. So this is my roster for CK. I only ran QC level 1 and QC level 2. If you remember from step 5, it wants you to wait 2 minutes before taking the first absorbance. So I waited 2 minutes, but really that was my 0 minute marking. So for QC1, I got 0.541 absorbance, and for QC2, I got 0.705 absorbance. I returned it to the incubator, and then right at 1 minute, I put it back to a spectrophotometer to read it, and I got it had increased to 0.574. And then QC level 2 increased to 0.771. Then I returned the cuvettes back to the incubator again. Then at the next minute mark, which is 2 minutes total now, it increased level 1 to 0.615 and QC2 increased to 0.856. I need to calculate the average change in absorbance per minute for each QC level. So to do that, I need to figure out the difference from 0 to 1 minute that it increased and the difference in 1 to 2 minutes that it increased. I'm going to take those two differences and find the average. And I'm going to do the same thing for QC level 2. There are a few ways to do this. I'm going to do it visually to help you understand, and I hope this one makes sense to you. So I have my three absorbance from 0 minutes, 1 minute, and 2 minutes. The difference from the first reading to the second reading was 0.033. And the difference from the second to the third reading was 0.41. In reality, if I was more accurate with my moving of the cuvettes from incubator to spectrophotometer read, these two numbers should be very close to one another. It's not perfect, but again, it's not very far off either. But it's asking for the average change in absorbance per minute, so I need to find the average of this. So I'm going to add them both and then divide by 2. I'm sorry, there should be another 0 here. So the average change of absorbance every minute is 0.037. So we need to do the same thing again for QC level 2. I have 0.705, 0.771, 0.856. So the change in absorbance from reading 1 to 0.2, I'm just going to simply subtract the 0.771 subtracted from 0.705. And there was a change of 0.066 absorbance between the first and the second reading. And next I'm going to take the difference, so I'm subtract 0.856 minus 0.771. So the change of absorbance from reading 3 to reading 2 was 0.085. Again, ideally they should be almost the same number, but this is not ridiculously far. And I'm going to find the average of these two change of absorbance. So add them together, divided by 2 is 0.0755. So now I have my two average change of absorbance per minute. So let's take a look at the equation they gave you. So the basis of this is the change of absorbance per minute over the NADP at 340 nanometers. So this is a given value. So if we were using this wavelength, it's going to convert to 0.00622, and that goes underneath the change of absorbance per minute. Multiply by the total volume, which is 1.05, because we have 1 milliliter of water and 0.05 milliliter, sorry, not water, 1 milliliter of working reagent and 0.05 milliliter of quality control or patient, and that's our total volume, over the sample volume. And again, our sample volume is 0.05 milliliter. This is not microliter, but milliliter, how they wrote this out. So they already did the math, so they divided the total volume by sample volume, and then they cross-multiplied by the NADP 340 nanometers, which is again that 0.00622, and they simplify this equation. So to make it easy, all you have to do now is take your change of absorbance per minute, which we already did for QC1 and QC2, and multiply by 3,376, and that would give us the value of our result. Okay, so I wrote that out here for QC1. Average change of absorbance was 0.037 times that given number 3376, and I'll punch that into the calculator, and I got 124.9. And then for level 2, my average change of absorbance was 0.0755 times that given 3376, and I got 254.88, so I can round that up to 9. And then I need to take a look now at my QC expected results to see what I should have gotten. So now I'm going to take a look at my QC value sheets for level 1 and level 2 to see how well I did performing this test and my pipetting skills. So this is CK/CPK. We're going to use general assay. So for level 1, it's 129 plus or minus 39. And I'm not even going to do the math because 124 is really close to 129. And then our CK for level 2 is 267 plus or minus 80. So again, that is very close. So I'm not even going to calculate the 2 standard deviation. So I know my QC level 1 and level 2 for this test pass. So I hope this demo helped you out and you can perform this test yourself.